Welcome to Inside the Item channel. We're exploring smartphone internals. Smartphones are complex devices with numerous components. They enable communication and information access. The outer casing protects internal components from damage. It's made of materials like metal or glass. Removing it reveals the intricate layout inside. The smartphone's internal layout is a marvel of modern engineering. It includes the motherboard, battery, and display. Each component plays a crucial role. The motherboard is the main circuit board. It connects all hardware components, enabling data transfer and processing. Its design is highly optimized. The battery provides power to the device. Its capacity and type affect the smartphone's overall performance and lifespan. Efficient power management is crucial. Understanding smartphone components is essential for appreciation and maintenance. In this series, we'll delve deeper into each part, exploring their functions and importance. The processor and motherboard are crucial components. They handle calculations and communications. The processor executes instructions, while the motherboard connects hardware. The processor's architecture is complex, with multiple cores and threads. It manages data and instructions, utilizing cache memory for efficiency. The motherboard supports this functionality. The motherboard acts as a communication hub, connecting peripherals and hardware. It enables data transfer and instruction execution, supported by the processor's capabilities. The processor's core components include the control unit and arithmetic logic unit. These handle instruction decoding and data processing, respectively. The motherboard's chipset manages data transfer between components. It optimizes performance, ensuring efficient communication between the processor, memory, and peripherals. In conclusion, the processor and motherboard form a symbiotic relationship, enabling the system's brain to operate efficiently. Their combined functionality is essential for overall performance. RAM, or random access memory, temporarily holds data for processing. It's volatile, meaning data is lost when power is turned off. RAM is essential for computing, enabling fast data access and processing. ROM, or read-only memory, stores permanent data that's not lost when power is turned off. It's non-volatile, providing a stable storage solution for critical system files and firmware. Data storage solutions have evolved significantly, from traditional hard disk drives to solid-state drives and flash storage. Each technology offers unique benefits such as speed, capacity, and reliability. Hard disk drives use mechanical heads to read and write data on spinning disks, offering high storage capacities at a lower cost. However, they're slower and more prone to mechanical failure. Solid-state drives, on the other hand, use flash memory to store data, providing faster access times, lower latency, and increased reliability. They're ideal for applications requiring high performance and speed. Flash storage, such as USB drives and SD cards, offers a portable and convenient storage solution. It's widely used for data transfer, storage, and expansion, providing a versatile and compact storage option. The battery is the heart of the device, powering its operations. It converts chemical energy into electrical energy. Lithium-ion batteries are commonly used due to their high energy density. The battery's internal structure consists of multiple cells, each containing a positive cathode and a negative anode. The electrolyte facilitates the flow of ions between the electrodes, enabling the chemical reaction that generates electricity. Charging the battery involves reversing the chemical reaction, allowing the device to replenish the battery's energy stores. This process is managed by the charging circuitry, which regulates the flow of energy into the battery. Power management is crucial to ensuring the device's efficiency and longevity. The power management system regulates the flow of energy from the battery to the device's components, optimizing power consumption and minimizing waste. The device also employs power-saving technologies, such as dynamic voltage and frequency scaling, to reduce power consumption during periods of inactivity or low usage. These technologies enable the device to conserve energy and extend its battery life. In conclusion, the battery and power management systems work in tandem to provide a reliable and efficient source of power for the device. By understanding these components and their functions, we can appreciate the intricate dance of energy and technology that enables our devices to operate. The display is the phone's primary interface, showcasing vibrant visuals and responsive touch input. It's an OLED panel, offering deep blacks and vivid colors. The screen is protected by Gorilla Glass, a durable and scratch-resistant material. The phone's cameras are equipped with advanced optics and sensors, capturing high-quality photos and videos. The multi-lens system enables features like portrait mode and zoom. Camera software enhances image processing, applying algorithms for optimal results. External connections are crucial for expanding the phone's capabilities. The USB-C port enables fast charging and data transfer, while wireless connectivity options like Wi-Fi and Bluetooth facilitate seamless interactions. The phone's interface is also home to various sensors, including proximity and ambient light sensors. These components work together to create a seamless user experience, adjusting settings and optimizing performance. As we reassemble the phone, we see how each component works together in harmony. The display, cameras, and ports all contribute to a cohesive user experience, showcasing the device's complex technology. The phone is now fully reassembled, and we see it in action, enabling daily interactions and connections. Thanks for watching. If you haven't subscribed yet, hit that subscribe button.